and then y will be negative 1. Is negative 1 plus w, so it's a negative plus t. X is going to be 2 minus w, so it's going to be 2 minus t. So it's you are going to be able to represent all the solutions by this parameter t. Okay. This one. Okay. Here we have 2 rows and 4 variables. Okay. And then if you represent this one by matrix, by augmented matrix, okay, a quick, elementary operations will tell you this is like a row echelon form already. Okay. Again, you have you have 2 non-zero rows, but you have 4 variables. So in this case, okay, you can name y to be s and w to be t. Then, okay, your z is going to be -2 plus 2w, so -2 plus 2t. X is going to be -2s plus 2t. So actually, you can put them like this. Write the solution in a form of matrix 2. This is like the 4 rows, 1 column, right? 4 by 1. Or you can say it's a column vector, okay? Whatever you want to call it. Of course, you can also do the same for this one. So then the answer will be like this. The column vector and form are going to be like that. And if you consider the parameter as a freedom, degree of freedom, you can see that here, okay. I mean, of course, we haven't discussed this yet, but you can see that, okay, you have 3 non-zero rows and 4 variables, so you have the degree of freedom is 1. And you have 2 non-zero rows and 4 variables, so the degree of freedom for your solution space is 2, because you have S and T, 2 parameters. Eventually, we will talk about this in more detail, more formal, at later time. So this is like an algorithm for Gaussian elimination. I will not go into the detail, but once you know how to do this process, I think that you can write algorithm to automate this process easily, right? Supposedly, if you are second year in computer science, okay, so you should have this ability, okay. Once you know how to do this, by hand, manually, then you should be able to write a program to get the job done. Okay. Honestly, a lot of this matrix manipulations now can be done by computer software. Okay. Like Mathematica or what's this? That's a software that has been used by EE people all the time. What's the name? 有一个EE他们都一直在用这个叫什么东西？也是N开头。我数一下。 校里面那个，一下忘记了。可是 anyway, all these matrix manipulations can be done easily, and also like NumPy, right? NumPy provides all the tools that allows you to do the matrix manipulations. Okay, so I just want you to understand all these things. I mean, obviously that have been automated by computer science. Okay, but you need to know the underlying is automation, what is the basic idea? Gaussian combination. Okay. So last one. Okay, polynomial curve fitting. If you have n points, x1, y1, x2, y2, x1, yn, you want to find a polynomial equation for px equals a0 plus a1 x plus blah plus n minus 1 x n minus 1, which pass through all these n points. Okay, you have n points. Okay, then you plug in these n points. It's going to give you n equations. So therefore, you can solve these n variables. In this case, the variables are a0, a1, blah, 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 an minus 1. So from a0 to an minus 1, you have exactly n variables, right? And you have n equations because you have n points. Probably these n points. Okay? So one example, find from polynomial px equals a0 plus a1x plus a2x squared that pass through the points, these 3 points. So plugging these 3 points, you get like a 3 linear equation for a0, a1, a2. And then we try to use this Gaussian elimination to solve this thing. Okay, this is actually Gaussian Jordan elimination because you eventually convert it into like a reduced Gaussian form. So you have like a0 to be 24, a1 to be minus 28, a2 to be 8. So your polynomial is like that. Okay, it will go through these 3 points. The similar idea can be applied to more points. So here, okay, we have like degree of 4, okay, polynomial, and you will pass through 5 points. Okay, so obviously you are going to end up with like a huge matrix. Okay, it's a 5 times 6 matrix. Okay. And eventually, you can solve this matrix to find the solutions for a0, a1, a2, a3, and a4. Okay? So that's why it's quite a polynomial. This is degree of 3 has to be like 4 points. Okay. So I think like I will not go through like this because this takes some time to solve that. But the basic idea is already represented here. Okay, so I think like we will stop here. Okay, these 2 examples I will let you guys to practice. So these things can be the material for quiz. That's it. Okay, remember, next week we'll have the first quiz. And I suggest you, I will give you like practice question, obviously, like later tonight, so that you can practice. But obviously, the first quiz is the easiest. Why? Because you cover only 1 lecture, right? You only cover 1 lecture material. Okay, so I hope like you perform well because like I will count only the 4 highest grades from the quiz, right? So I hope like you perform well on the first quiz, okay? Which which will be filled out next week. Okay? So any questions? If no question, I will see you next week. Okay? That's it. Okay. This is a chapter review of the problem.